Hi, Assalamualaikum and very good morning. My name is Amir Zahir bin Abu Hanifah Lim, metric number B0821104442. Today I would like to present about the MOSFET metal oxide semiconductor. MOSFET have characteristics similar to JFET and additional characteristics that make them very useful. Today there are two types of MOSFET, depletion type and enhancement type. I will focus more on depletion type. This is the symbol for the MOSFET, depletion type, N channel and P channel. You can see the difference, the arrow. Once is go in and once is go out. Depletion type MOSFET construction. The drain D and source S connect to the N-doped region. These N-doped region are connected via N channel, and N channel is connected to the gate via a thin insulating layer of SiO2. The N-doped material lies on a P-doped substrate that may have an additional terminal connection called substrate SS. You can see from the picture, this is the drain, N channel, P substrate, N-dope, source, drain, and substrate. Basic MOSFET operation. A depletion type of MOSFET can operate in two modes, depletion mode and enhancement mode. I will go on for the depletion mode. So you can see from the graph, this is a depletion mode, from this to this. Okay, next I will pass to my friends.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh, and a very good morning to our lecturer and our fellow friends. Okay, my name is Muhammad Shazwan Saifuddin bin Salihuddin, number matric B0X 2110428. I'm from BEI section 2/1. Okay, today I'm going to continue about operation mode in depletion types. Okay, as we can see here, they have two mode of operation with its depletion mode and enhancement mode. Okay, for the first one, depletion mode, the characteristics are similar to JFET. When VGS is equal to 0 volt, ID also equal to IDSS. When the total VGS is lower than 0 volt, ID also is lower than IDSS. And then the formula used to plot the transfer curve still applied for both mode, as we can see here, the formula. And then for the enhancement mode, VGS is higher than 0 volt, and also ID is increased above IDSS, and note that VGS is now a positive polarity. Okay, and then we go for the basic operation. As we can see here, they have two figure. The first one is described as N-channel depletion type MOSFET with VGS is equal to 0 volt and applied voltage VDD. Okay, for the next one is a reduction in free carries in a channel due to a negative potential at the gate terminal. Alright, we can go for the P-channel depletion type MOSFET. As we can see here, they have two plotted graph right here, first and second. So described as the P-channel depletion type MOSFET is similar to the N-channel except that the voltage polarities and current directions are reversed. Okay, lastly, for the symbol, we can see here they have two channel. The first one is N-channel and the second one is P-channel. For the N-channel and P-channel, they have not so much different. As we can see here, they have the same figure, but the main difference between them is the direction of this arrow. For this arrow, we can see for the N-channel, both arrow is moved to the left side, while the P-channel, both arrow move to the right side. Okay, so that is the main difference between this symbol.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Syabin Burhan from 1B AI. Today in this video, I will present about enhancement type MOSFETs, which is as stated in the picture. We will determine the VGSQ, IDQ, VDSQ, VDS, VD, and VS in this circuit. For the first one, 1 mega ohm resistor is short circuit due to the IG equals to 0. So VGS equals to VDS means VG minus VS, which cause 22 minus ID times 1.2 kilo ohms minus 0.51 times ID. So for the first equation, VGS equals to VDS, which means by 22 minus 1.71 kilo ohm. That is for the first equation. For the second equation is ID on is equals to K times in the bracket of power of 2 VGS on minus VGS Thevenin. That is for the second equation, and for the third equation is K equals to 5 milliampere over in the bracket of power of 2 7 minus 4, which is 5 over 9 milliamp over V square. That's for the equation 3. So we just multiply the equation 1 and 2, which is ID equals to 5 over 9 times 10 power of negative 3 times in the bracket of 22 minus 1.71 K times ID minus 4 in the bracket of power of 2. So from the equation we calculate, at the end of the answer we will get 8.25 milliamp. So by that, ID is equivalent to IDQ, which means IDQ is also same value with ID, which is 8.25 milliamp times ID. So it also equivalent with IDQ, and so therefore the IDQ will equals to 8.25 milliamp. And then for now, VGSQ is equals to VDSQ, which mean by that 22 minus 1.71 K times 8.25 milliamp. We just multiply with the value that we get from up value. So the answer for VGSQ is 7.9 volt. So as you know, VD is equals to VDD minus ID times RD. So we just substitute the value. So 22 minus 1.2 K times 8.25 milliamp. So the final answer is 12.1 V. So then for VS, the formula for VS is VS equals to ID times RS. So we just substitute the value. So 0.51 K times 8.25 milliamp. So the answer for VS is 4.21 volt. So when we got the answer for VS, we will get answer for VDS. So the formula for VDS is VD minus VS. So same like before, we just substitute the value 12.1 volt minus 4.21 volt. So the answer for VDS is 7.9 volt. That's all. Thank you.
Assalamualaikum. Next for question 2 is to determine the VGSQ, IDQ, VDS, VD and VS. For figure 2 is a E MOSFET bias circuit. Proven by the calculation, to find VGSQ and IDQ, we need to calculate for the VGS at equal negative 6 volt, which is ID is equal to 0.25 milli multiplied by, in the bracket was 9, is equal to 2.25 milliampere. And for the VGS at equal negative 8, we can get the ID is equal to 0.25 milli, in the bracket was 25, so it's equal to 6.25 milliampere. So from the information we get here, the ID, we plot it for 2.25 milli is over here, and 6.25 milli is over here. So we plot the graph. Then the next one is VDS is equal to VDT minus by ID multiplied by RT. So the VDT was negative 16 minus by the ID was 4 milli and the RD was 2 k ohm. So it's equal to negative 24 volt. Next, the VD is equal to VDS and the VS equal to 0. So based on the graph, VGSQ equal to negative 7.5 volt and IDQ was equal to 4.5 milli. So the improvement was here from negative 16 VGS and the highest ID 8 was VDD over RD, and then we can get from the 4.5 milliampere is over here and the VGSQ is 7.5 volt negative. So that's all from me. Thank you.
Okay, so next we're gonna move on to the multi-sim.
We have been given to solve question 3 using a Simulink. Show a voltage divider bias circuit for the MOSFET. I will present for find VGSQ and IDQ. So this is the question. This is a circuit that I use for to find VGSQ. We need to place positive probe at here and negative probe at here. Run. Okay, this is for VGSQ. Okay, for find IDQ, we need to connect multimeter in series. Okay, run. Okay, this is IDQ. Okay, next my friend will continue.
Alright, we're gonna go for the simulation. First of all, okay, we're gonna go for the VDS. So we're gonna take the multimeter and put right here. Then we put it between resistor 2 and the resistor 4. Run it, and yes, this is the total value for VDS, 21.56 volt. Okay, we have gone for VDS. After that, we're gonna go for VD. Alright, for the VD, put the multimeter, same multimeter we use, put it right here, and put it between the resistor 2. Okay, run, and yes, we got the value for the VD, which is 1.819 volt. Okay, and for the last one, VS, take the same multimeter. Okay, put the first one right here and the second one right here, and you use the same method, run, and we get the value for the VS, which is 620.255 millivolt. Alright. That's it. 2156 18 19 and 620.255 millivolt. Thank you.